Do some definite integral practice questions here. So you have these questions in front of you. So remember what we need to do is we need to do u substitution. Then we need to change the limits of integration from x values to u values. Then we can go ahead and finish the process, the fundamental theorem of calculus process, the integral or the antiderivative evaluated at the upper boundary there, okay, or the upper limit of integration, minus the antiderivative evaluated at the lower limit to give us our value. So, u substitution, we want to identify a u. What's the u value for number 1?
X plus 3.
Very good, x plus 3, because it is definitely inside an outer function which would be square root of u, right? So du is 1 dx. So du is equal to dx. This one's pretty easy. Now, when x is 6, that's the upper limit of integration. What is u? U is?
9.
U is, whoops, that's a funny u. U is 9, correct. When x is 1, that's the lower limit, u is 4. Okay, so I can rewrite this integral now with my new limits of integration. That's 4 to 9. And then simply the square root of u, and dx is equal to du, so there you go. Now, you might want to change the square root of u to the 1/2, right? You want to view it that way so we can take the antiderivative. So now this then equals, well, I add 1 to 1/2, right? So that's 3 over 2. So I divide by 3 over 2, or multiply by 2 over 3, u to the 3 over 2. Now, am I going to have to do plus c here, like that?
No.
It's a definite integral, so no, we don't have to do that. Instead, what we're going to do is we're going to evaluate this from 4 to 9. Okay? So look good so far? All right. So in doing that, let's see, we have, I can pull this 2/3 out if you want to, you can. And you can just go 9 to the power of 3 over 2 minus 4 to the power of 3 over 2. So that's 2/3 times, what's 9 to the power of 3 over 2? Remember, the 2 in the denominator is the square root. So that's 3 cubed. That is 27. Minus the square root of 4 is 2. Cubed is 8. So it's 2 times, what was that, 19? Over 3, or 38 over 3. Now, again, you do not have to put units squared. Units squared would be what you would put if you knew it was an area. We're just finding a definite integral is not necessarily an area per se. Okay, how was that? Is that pretty good? You guys okay with that? Can you guys see that all right back there? I just feel like I need to zoom in just a bit. Should I do that? Is that better? Maybe, maybe not. Okay, so this one right here, I'll change colors here for you to maybe red. Let's do red. So for number 4, notice that this dx is up here in the numerator. It doesn't have to be. Dx can be here. If you'd like it better there, you can envision it that way if you want. It's okay. This would be a 1 over x squared plus 1 to the power of 3, or an x squared plus 1 to the power of negative 3, however you want to look at that as well. So what would be our u? That's where we want to start. U is?
X squared plus 1.
Yeah, it's an inside function, and here's an outside function. Here is the third part, the portion of the derivative of the inner function. So u is x squared plus 1. Of course, we always do du right away. That's 2x dx. Okay, very good. Now, do I have 2x? Do I have the full derivative? I'd need a 2. So let's put a 2 up here, and to counteract that, I would multiply by 1/2 outside the integral. The other thing we would need to do is find out what u is when x equals 2 and when x equals 0, because we do need to change the limits of integration here. So u is x squared plus 1, so if x was 2, we'd have 2 squared plus 1, which is 5. And if x was 0, which is our current lower limit, then we would have to go 0 squared plus 1 is 1. So now I can fully rewrite my integral here. So I have 1/2 the integral from, it's in terms of u now, so the limits have to be in terms of u, from 1 to 5 Now the 2x dx from up here,
Mr. Glassfeld, please
this
call
simply is
205.
du.
Mr. Jeff Glassfeld, please call 205.
And I have 1 over u cubed. Okay. So that's your u substitution and changing your limits to values that are u values and not x values. So now we go ahead and find the antiderivative of this, right, which is pretty easy to do. That's actually equal to u to the negative 3. So I'm going to add 1 to that, and that new exponent is going to be negative 2. I'm going to divide by negative 2 as well. And I can't forget my 1/2 that's already there. So it looks like I have to multiply by 1/2 again. And we're going to evaluate that from 1 to 5. Let me know if you're all okay with what we've done so far here. Okay, I'm going to change colors again here. Let's just refresh this a bit. That's going to be negative 1/4, right? And I can take that constant out really of this. It's going to be u to the negative 2 minus, u to the negative 2 again. So let's fill that in. So u is going to be 5 to the negative 2, right? 5 to the negative 2 minus, and this u here is now going to be 1. So 1 to the negative 2. Does that look good? I've combined this, and I'm doing capital F of this minus capital F of this. Okay, which is negative 1/4, and this is 1 over 25, and this is minus 1. Okay, which 1 is actually 25 over 25. I can change that right away. So I have negative 1/4 times negative 24 over 25, which is going to be positive. I can simplify 24 over 4, which is going to be 6, I guess. So 6 over 25 should be your answer. Okay. Okay, so there's examples or questions number 3 and 4. Any questions at all about what we've done here? All right, I'm going to give you now a few minutes to do number 5 and just see if you can do it on your own. If you run into troubles, it's no problem. I'll help you out in a minute, but why don't you give number 5 a try. Noticing that you're going to have a u, you're going to have an outer function as well, and you're going to have at least a portion of the derivative of u in there as well. So go ahead and give that a shot. All right, so hopefully you've had a chance to do this one. It's a bit tricky, big numbers. But yeah, what we want to identify here is, this is the tricky part here, right? This is 6x plus 15 dx. We see that we have, and I didn't finish this, we have 2x plus 5 dx, right? So in order to make this, I have to multiply the existing expression by 3, divided by 3, or multiplied by 1/3. So if I introduce this into the integral, I need to counteract that by putting a 3 outside. So now I do have, this is du, so that's why I put du there. Trade this in for u, and here we have this integral right here. So taking the integral of u to the 4th is easy. 1/5 u to the 5th. Once you evaluate this here on the right, this should be your answer. And I think we have some agreement there. Everyone got that? Okay. All right. So any questions there? There's 3 solid definite integral. So we're combining u substitution, which is important, plus the idea of the definite integral and the evaluation of that. So there's your 3 questions for practice today.
And